Welcome back to Unit 2 video lesson number 4 on isotopes. So let's get started with it. Henry Moseley, who was a colleague of Rutherford, actually he was a student of Rutherford, he found that every element had a unique positive charge in its nucleus. And what I mean by a unique positive charge, he determined that the number of protons, so he found that every element had a unique number of protons in the nucleus, and that this number of protons in an atom identifies it as an atom of that particular element. So the number of protons identifies the atom, and it never ever changes. All atoms of the same element have the same number of protons. That never changes. And this was the birth of the atomic number. The atomic number is equal to the number of protons in the nucleus of an atom. And as I said, it never changes for that atom. If you change the number of protons, you change what the element is. In a neutral atom, and we know that all atoms are electrically neutral, the number of protons is equal to the number of electrons. So if you know the atomic number, which is found on the periodic table, that not only tells you the number of protons, but it also tells you the number of electrons. Now, Dalton stated that all atoms of an element are identical. But since then, it has been found that some atoms of the same element have different masses. And so the question is, what subatomic particles, that is, what particles in the atom make up the mass of the atom? And from the previous lesson, we learned that. And think about it. We learned that the protons and the neutrons make up the mass of the atom. Remember, the mass of the electron is so small that it's considered negligible. So it's the protons and neutrons that make up the mass of the atom. If the masses of these elements are different, then what particle contributes to the differences in the mass? And think about this, because I just said that the number of protons of an atom of an element never ever changes. So the subatomic particle that contributes to the difference in the mass has to be the neutron. These atoms are called isotopes that differ in the masses, and the atoms of the same element that have different masses have different number of neutrons. They're depicted by what is called the mass number. Mass number is equal to the number of protons plus the number of neutrons. Carbon, for instance, has 6 protons and 6 neutrons, and so this isotope of carbon has a mass number of 12. Well, carbon has another isotope. The number of protons doesn't change. You still have 6 protons, but this isotope has 8 neutrons, and the mass number is equal to 14. So 2 different isotopes of carbon, one having a mass number of 12 and the other having a mass number of 14. But what is exactly the same, what makes them isotopes of carbon, is the number of protons. They both have 6 protons. And if they're neutral, then they would have 6 electrons each. There are 2 notations for isotopes. One is called a hyphenated symbol, and then we also have a nuclear symbol. Let's take a look at the hyphenated symbol first. In the hyphenated symbol, you're going to write the symbol of the element, hyphen, and its mass number. So if we take a look at the 2 carbon isotopes, the hyphenated symbol for those would look like this. Carbon hyphen 12, and it's red, carbon 12. And then you have carbon hyphen 14 and red carbon 14. So that number after the symbol is the mass number. The nuclear symbol, on the other hand, I think gives more information than the hyphenated symbol, because you have the symbol of the element, and then superscripted on the left-hand side you have the mass number, and then below the mass number you have the atomic number. So carbon 12 would look like this. You have the symbol for carbon, superscripted 12, the mass number, subscripted 6, the atomic number, and the same thing for carbon-14. We superscript the mass number and we subscript the atomic number. Now the cool thing about this is if you subtract these, that gives you the number of neutrons. So if we subtract these two, carbon-12 has 8 neutrons. Oops, no it doesn't, it has 6 neutrons, I'm bad. And if we subtract these two, we see that carbon-14 has 8 neutrons. How many electrons would they have? Well, they'd both have 6 electrons each because they're electrically neutral. So let's take a look at this chart that I have here. So mass number we know is protons plus neutrons. The atomic number is the number off of the periodic table. The protons is the atomic number. So the atomic number gives us the protons, which is equal to the electrons. Okay, and then the neutrons, you're going to get the neutrons by taking the mass number and you subtract the number of protons. And that gives you the number of neutrons. The electrons, well, is equal to the number of protons, or the atomic number. So if we take a look at this, K is potassium, it's on the periodic table. This is the hyphenated symbol. The number that follows is the mass number. Okay, so we can come over here and put that the mass number is equal to 39. Now, how do we find any other information? Well, the atomic number is on the periodic table, and if we look on the periodic table for potassium, we see that its atomic number is 19. So what does that tell us? Well, that also tells us you have 19 protons. That also tells us that you have 19 electrons. And then how many neutrons would you have? Well, you take the mass number, 39, subtract the number of protons, and that gives us 20 neutrons. Okay, so given any of this information, we should be able to figure out the rest of the information about that isotope. Let's take a look at this nuclear symbol. So we would put potassium. We have the mass number, which is superscripted, that's 39, and then the atomic number, which is 19. And that would be our nuclear symbol. So let's go to the next one. We have atomic number 19. Well, atomic number is equal to the number of protons. That's also equal to the number of electrons. We look on the periodic table and we see that that is potassium. We're given that we have 21 neutrons, so if we add the two together, the protons and neutrons, then we get a mass number of 40. And so this is potassium 40. Nuclear symbol K, mass number written above, and then atomic number written below. Okay, so that is how we can use what we know about the atom, its atomic number, its protons, neutrons, and electrons, to write both the hyphenated and the nuclear symbol for the isotopes. And that is the end of video lesson number 4 on atomic structure. Until video lesson number 5, this is Mrs. Weethy, so long for now.